Assalamualaikum and very good evening to all of you. I will give you some briefing about the experiment 1, which is a voltage divider and operational amplifier. So on this experiment, you need to construct a voltage divider, voltage follower and non-inverting amplifier. And then after that, you will apply this all circuit to signal conditioning. So let's go through the voltage divider. As we know, right, why we need the voltage divider? Some of the sensor, some of the actuator need a certain voltage, right? So we can use the voltage divider. So a simple components that used for voltage divider, we call it a potentiometer. So potentiometer have the VS, right? Voltage ground actually, and this is the voltage output, right? That we can get in the certain voltage here, and then we shut it to ground. So there are simple formula that we can get here, right? V out here, so and V in here, and this one, the R1 and R2 is variable resistor that we can adjust. So it is a simple thing. And what is the OM? OM is a device that used to amplify and attenuate. Attenuate that means you can de-amplify. Okay, that means if you put here is 1 volt, you can amplify it to 10 volt, for example. If you put here is 10 volt, you can de-amplify to 1 volt. Okay, it depends on your application. And for the ideal amplifier, has an infinity input impedance here, Zi, and also output impedance here will be more equal to 0 ohm. Okay? And you can use this OM or this device for a basic configuration for voltage follower, inverting, non-inverting, and so on. And overall, it depends on your application. So this is the type of OM that you can use, right? It's an IC, integrated circuit. So right now we use the LM324N. So it can give you 4 output, right? That means you can have 1, 2, 3, and 4. 4 set of input, and also you can get it 4 set of output. Okay. And when you play around with the OM, there are one words that you need to be careful. We call it is OM saturation. OM saturation, that means we cannot get the output more than the supply. That is the concept. Okay. So for example, uh, this one you can get it from your data sheet, right? So if you give the supply V plus or V minus, so that means this OM can operate by two operation, which is single. When you put it VCC, that means a positive supply and also ground, or dual supply when you put it plus supply or negative supply. Okay, so according to the data sheet, it depends on your OM that you buy. Okay, so if you put the uh, OM, right, as the dual supplies, right, so the maximum output that can deliver by this OM is you need to minus with 1.2. Okay, so for example, like this one, if you use plus minus 15 volts and with the 10 load K, so the output can swing between minus 14.5 volt to 13.8 volt. Okay, so let's make clear about it. It's a simple thing. Look at this one. So this is your OM. Okay, minus and plus, and this is your supply. Okay, so let's do a single operation. For example, you put it here is 5 volt, and this one is ground. Okay, and this is your output. So when I put it, let's say this OM, the gain is 10 volt, right? So when I put it, the input is 1.0 0.1 volt. So time with 10, so you should get 1 volt, right? Okay, and 0.5 volt, you should get what? 5 volt, right? 0.5 times 10 equals 5 volt. But this one in theoretical, yes, theoretical. Yes, you can get it. But in practical it, so you need to minus a 1.2 here, right? So in this case is you will get it is 3.8 volt the maximum. Okay. So when you measure this one, you will get the maximum is 3.8 volt. For the input is 0.5. This is the concept. Okay. All right. So let's continue. All right. So OM as the voltage divider. Okay, OM as the voltage follower. Okay, some of load with low input impedance like speaker, right? So you have the output here like speaker. You withdraw a huge amount of current. Okay, because the OM had a high input impedance, so they don't draw a lot of current and they also don't load down the power source. Okay, so OM can be configured in the voltage follower. The circuit is just like this one. Okay, so this is your input, right? The power source, all right? And then this is you need to shut it here. So the formula is V out here will equal to V in here. This simple OM. And why the voltage follower is very important. So let's say you have the load of motor, for example, with a certain 100 ohm that need 5 volt to operate. So final calculation so that the output through the load is 8 and 99.8 millivolt. Okay, so if you see these two circuit, right? So this circuit will not work. Why? Because when you use the voltage divider concept, right? So you will see that this voltage is not enough. Okay, right? It's not enough to 5 volt. So you need the voltage follower here. Okay, right. So next, the OM can be used for non-inverting, right? Non-inverting, that's mean if you configure this OM, right? For the non-inverting, that's mean you need two resistor here, R1 and R2. R1 and R2 for the gain, okay? And that's means when you have the input voltage here, it will amplify, but it will not invert it. That's mean when you have the positive supply here, so you will got the positive supply here. Okay, so the formula is V out equal to 1 plus R2 divided by R1 you time with V in, right? So and the gain is 1 plus R2 over R1. Okay, right. And for the experiment, you will construct all the experimental circuit. This one is the voltage divider, potentiometer here, and you will read the value from the multimeter one, right? You will adjust the variable resistor here, and then the second circuit is the voltage follower, and you will read the value from the meter 2, right? But theoretically, VF, that's mean voltage follower, will be equal to V in because the gain is only 1. And after that, you put it into non-inverting circuit. It depends on your gain here. So right now, the gain is 1 over 1 is 1 plus 1. That's mean 2. Gain is 2. And you will get the output from the meter 3. Okay. So V OM, that's mean voltage amplifier will be equal to this one again with time with the input PF. Okay. And this is the component you will use in your experiment. Okay, and the
Hello, I'm Abdul Rahim. In this video, we look at the operation and setup of a simple voltage divider and op-amp circuit. Note, before we start constructing the circuit, please refer and read the SEMM 2921 online lab sheets. Please take note of the potential hazard of the electrical shock and burns when constructing this circuit. From the circuit in the lab sheet as in figure 5, I have constructed the circuit on a breadboard shown in this video. The equipment and the components that are used in this video are the DC power supply, which reads fixed 5 volts, and 10K potentiometer for the voltage divider. LM324N, we are using 2 out of 4 op-amp from the chip. The resistor 1K and 2K, and digital multimeter. Multimeter 1 reads the voltage divider output. Multimeter 2 reads the voltage output of a voltage follower circuit. Multimeter 3 reads the output voltage of a non-inverting amplifier circuit. The procedure. Referring to table 1 in the lab sheet, rotate this potentiometer so that the digital multimeter ones read V in at 5 volt. Read and write the value of the voltage follower output in the digital multimeter 2 in the table. Repeat the procedure as shown in table 1. Next, referring to table 2 in the lab sheet, rotate the potentiometer to the value of V in as shown in column 1. Read and write the values of the non-inverting amplifier output of each V in changes in the table as shown in multimeter 2. For the next experiment, by referring to table 2B, replace the value of 1K, this R2, 1K value to 2K value. Repeat the experiment by changing the value of V in. Record the values of the non-inverting output through the multimeter 3 for every V in changes. That's all. Thank you.